Pre-Algebra students. Today we're talking about lesson 85. Yay, we're starting new material. So this lesson is equations of a line and graphing a line. So the beginning of your lesson just talks about writing equations and what solutions look like. So it starts off by saying if you have one variable, your solution is going to be that one number that you would substitute in for the variable to get a true statement. So for example, x plus 2 equals 5. If this is my equation, it has one variable, and so there's only one answer that will be able to plug into x or substitute in for x to make the statement true at the end, and that number is 3. So x equals 3 is my solution on that one. But sometimes we're going to have two equations with two variables, and so those solutions would look like a pair of variables that make the statement true. And there's an infinite number of combinations that we can choose here. So if we use 3 for x, for example, and my equation is y equals x plus 2, 3 plus 2 is always going to equal 5. So my combination would be an x value of 3 and a y value of 5, because that would make my statement true. Another example would be if I use 7 for my x, 7 plus 2 equals 9. So my combination here for the solution would be 7, 9. These are both solutions to this equation. And so what we're going to do today is we're going to actually graph these solutions on a rectangular coordinate plane. And if we were to graph them on a coordinate plane, it's going to look like a straight line because the x is just an x. It's not an x squared, it's not an x cubed, it's not the square root of x, it's just a regular x, and we call this a linear equation because it looks like a line. So we're graphing these lines. I'm just going to do one example. It takes 2 points to determine a line, but we're actually going to find 3 points just so we make sure that it's pretty clear. Okay, so if my equation is y equals x minus 2 and I want to graph that equation, what we're going to start out doing is just making an xy table. And you can pick any x value that you want. I like to pick small numbers, and usually I'll pick at least one negative and 0 and a positive. So I'm just going to do negative 1, 0, and 1 for my x values. And then I'm going to substitute in those x values in my equation. So if my equation is y equals x minus 2, then my equation is y equals negative 1 minus 2, and my y value would then be negative 3, because negative 1 minus 2 is negative 3. So my coordinate would be an x value of negative 1 and a y value of negative 3. And I'm going to do the same thing for my next one. Y equals 0 minus 2. 0 minus 2 equals negative 2. So my y coordinate here is negative 2. You should see a pattern, hopefully, but I'm going to go ahead and actually show my work with plugging in my last variable here, 1 minus 2. I'm sorry, 1 minus 2. So 1 minus 2 is equal to negative 1. And so my last y coordinate is equal to negative 1. Okay, so now once we have our table finished, we're going to graph it. So I'm going to draw myself a coordinate grid, an XY coordinate grid. I didn't leave myself very much room here, so it might be a little squished, but we need to go at least from negative 1 to positive 1. And then on the y-axis, I need to get down to negative 3. So I'm going to say negative 1, negative 2, negative 3. Okay, so here's my grid. This is my x-axis and my y-axis. And so I'm going to graph negative 1, negative 3, negative 1, negative 3 would be right here. And then I have 0, negative 2. And then I have 1, negative 1. And you can see it looks like a straight line, so I'm going to actually go ahead and draw my line through, because every single point that touches this line would be a solution to this equation. So we are going to draw a line through, and we're going to put arrows on the ends to show that this line keeps going forever because there's an infinite number of solutions.